So we'll discuss this problem, question number 5, given in the assignment. Let us have a little bit background information regarding rocket. So in case of a rocket, say if this is the rocket, let us say that this rocket is burning the fuel at the rate of dm dt. Its mass is burning, so mass is decreasing, the fuel is burning. So that means it's minus dm dt. And if there is a constant burning of mass, if the mass is changing, that means there is a momentum change. And we all know from Newton's second law equation, the force is V dm dt. Okay, so you can imagine that this V being inside the derivative, so that is basically d dt of mv. Okay, this is the force that is acting on the rocket. Now, because the V is the speed of the fuel with which it is ejecting out, this is the speed of the fuel. Let us make it V naught. Okay, so V naught. So V naught is the speed of the fuel. So that is minus V naught dm dt. This is the force acting on the rocket. So let us imagine that when dm mass is burned, this is the force that is acting on the rocket. M is the remaining mass of the rocket. So its velocity will increase by Newton's second law by this equation, m dv dt, because force is equal to m dv dt. M is the remaining mass and dv dt is the rate of change of velocity with respect to time. So I am assuming that this equation is okay for you. So if you cancel this dt, what we get is dm by m is equal to minus 1 by v naught into dv. So if you integrate this, is m naught is the initial mass. Initially, the rocket was at rest, and finally the rocket has speed v. At that time, this mass of the rocket, the remaining mass is m. So what we get here, it is ln m by m naught is equal to minus v by v naught. This means m is equal to m naught e to the power minus v by v naught. This is the mass of the rocket. So this is how the mass of the rocket is varying with respect to the speed. Okay. So now with this information in mind, we'll come to the problem. We'll try to tackle the problem. So what the problem is saying, for a rocket moving in free space, so this rocket is moving in free space. That means in vacuum, which is beyond atmosphere. The fraction of mass to be disposed of to attain a speed equal to twice the exhaust speed. So what is V naught? Remember, V naught is the speed of the burning of the fuel. That means this is the speed of the exhaust. And V is the speed of the rocket. So this means your V has now become 2V naught according to the problem. See, read the problem properly. The problem is asking that the rocket has to attain a speed equal to twice the exhaust speed. That means V has become 2V naught. So you put this data in the equation. So m is equal to m naught e to the power minus, instead of V, I'll put 2V naught by V naught. So m naught e to the power minus 2. Okay. So what I'm getting, m is the remaining mass, m naught was the initial mass. This ratio is e to the power minus 2. So the question is asking the fraction of mass to be disposed of. So how much mass is disposed of if m naught was the initial mass and m is the remaining mass, that is the final mass. So how much mass is burnt by the rocket? The final mass is obviously less than the initial mass because the mass is burnt. So the mass that is burnt is initial mass minus final mass. That means m naught minus m. So question is asking to find the fraction of this mass. So this means the fraction F is equal to m naught minus m. This is the burnt mass divided by initial mass. This ratio is asked. So the answer is 1 minus m by m naught. But 1 minus m by m naught value is e to the power minus 2. So the answer is 1 minus e to the power minus 2. Okay. So now just put the data, which is 1 minus 1 by e square. So this means 1 minus 1 by, and you can see that in the question e square is given as 7.4. So you put the data here 7.4. So this data I'm getting as 6.4 by 7.4, right? So 0.86, because 64 is very near to 74. So without solving, I can say that the answer is 0.86. You can just solve this value, find the decimal, cancel it out, and you can obviously convert it into decimal, and the answer will be 0.86. I hope the solution is clear. So just once go through this entire solution. So this is the information that you have to know before solving this. This is the equation of the rocket. And this equation is known as the differential equation of the motion of rocket. Okay. Thank you for watching.